We are here to hear about Minnesota's changing climate. Kenny Blumenfeld is back with us. He's been with us before. He's talked to us about forecasting weather by the clouds. He's talked to us about lightning strikes. It's been several years since we heard him talk about climate change. And so he's going to do an update. We've all noticed changes, that the winters aren't what they used to be. And we've heard about changes and some of their implications. But Kenny is an entertaining speaker, but he's also going to tell us about the science and about what kinds of changes we're seeing. Kenny is a climatologist with the Minnesota State DNR, and he presents a lot on these things. And he's entertaining enough that sometimes he talks about it at places like Bryant Lake Bowl. So I'm going to turn it over to Kenny.
Thank you, Fran, and thanks, everyone. It's good to be with the Rovers again. I think we must be at 5 or 6 years now. Barry reached out to me several years ago. I want to say it was 2017. That must have been the first one. And I think I did at least 3 in-person talks, one on I think climate change. I did maybe 1 or 2 on climate change, and I've done a couple on, as Fran mentioned, knowing how to kind of do survival weather forecasting, especially for thunderstorms when you're outside, and using clouds and the behavior of clouds to anticipate really potentially dangerous weather. And then the last time I was with this group, I talked about clouds and kind of the beauty and splendor of clouds. My main job is definitely as a climate change scientist for the Department of Natural Resources. But because this group is an outdoor affinity group, kind of kindred spirits, and I thought at times it's good to share other types of information. And as Fran mentioned, I do also keep doing this even on the side. Some of the material I have is definitely not represented by my work at the DNR, and I think they're appreciative that some of the work I do outside of office hours, business hours, they'd like to keep it that way, that it's not strictly affiliated with the DNR. So I do have kind of more entertaining, a little more freewheeling view of some of the climate change, in particular topics that I talk about occasionally at Bryant Lake Bowl. Okay, I'm going to start sharing my screen, and we will begin. All right, there we are. Does everyone see my screen? Very good. All right, thank you. So today we're going to talk about Minnesota's changing climate. I'm going to just see if I can shrink down some of these side panels here. So today we're going to talk about understanding our changing hydroclimate, or our changing climate, what differences we've seen in recent years, what changes we've seen, the trends. We're going to talk a little bit about trends, what they really are, and projections. This is kind of a deep dive into climate science done locally. So and this is about half of what I do for the State Climatology Office. State Climatology Office is a fascinating place. I feel like the luckiest person in the state, at least for the job I have. And I have great colleagues, and previous state climatologists have built a fantastic data system and data enterprise. And all I'm doing is just using the tools that other people have built to try and help Minnesotans understand their climate. Okay, so when we talk about climate and climate change, there's always some items to kind of bear in mind. I'm going to just see if I can get rid of this little headline. Okay, there. Okay, so there's some things to kind of bear in mind. One is that our climate is different from other places. It always has been. And so we think of, you kind of got to remember the big issue. The big issue is that global temperatures are increasing. I mean, that is at the heart of why we care about climate change. Global temperatures are increasing because there's additional greenhouse gases in the atmosphere, and those greenhouse gases absorb when the sunlight reaches the earth and the earth starts to get warmer from it. That heat gets radiated back into the atmosphere, and greenhouse gases do the job of retaining or holding on to some of that heat in the atmosphere. And when you add additional greenhouse gases to the mix, you start retaining even more heat than you would have otherwise. But the bottom line is that temperatures have been increasing on a global basis. And what this means is there's essentially more heat in the system, kind of, I don't want to say sloshing around, but there's just more of it. There's more heat in this, gaseous envelope that we call the atmosphere. And that's sort of at the heart of it. And then the question that everybody really has, the question that everyone's really trying to answer is, okay, what do global rising temperatures mean for me? I mean, I know it's kind of a selfish framework, but that's really what everyone wants to know. What's it mean for our weather here? What's it mean for our climate here? And what symptoms can we expect? Can we expect symptoms? And if you kind of start with that framework, then it's easy to understand that, well, Minnesota's sort of normal climate was always different from other parts of the country and other parts of the world, right? I mean, we have long and cold, and sometimes snowy winters, and then we have shorter but often very warm and humid summers, and sometimes they're quite stormy. And if you were to describe, California's climate in the same number of words, you'd probably have to come up with really different descriptors, or Florida's climate, or really anywhere kind of around the edges of the country or at the corners, certainly Hawaii. And then you could do the same thing internationally. It's just, there aren't that many places that share the climate of Minnesota. So we already have, and this is true everywhere. I mean, everyone's kind of got a different climate from everyone else. So it shouldn't surprise us that as global temperatures rise, and there's, that changes the amount of heat that can be distributed throughout the system, and that's going to fundamentally change some of the mechanisms for distributing that heat throughout the system, meaning that there's going to be changes in the weather patterns. It shouldn't really surprise us that our climate symptoms in reaction to rising global temperatures are different from what we see in other places. So that's kind of why geography really matters here. Here in Minnesota, we have our own symptoms that aren't necessarily shared elsewhere. When you talk about changing climate, this is point number 2. It's kind of important to remember that we have past and we have the future, and we're really concerned about both, because the past tells us where we're coming from. Everything that we've observed and measured gets us to right where we are right now. We have lots and lots and lots of information from rain gauges and thermometers and other kinds of instruments about where our climate has taken us up to this point. There's even, if you talk to certain types of geologists and ecologists who look at maybe pollen sediments, or even rock stratigraphy, or dendrochronologists who look at tree rings, there's even ways to go backwards beyond what we can measure with instruments to make other inferences about the climate. But all that can do, all of those things can only bring us up to right now, especially when you're adding heat to this system. They don't necessarily tell us where our climate's going to go in the future. So we need a way of understanding how to assess likely climate scenarios for the future. And that's where projections come in. And when most people hear about climate change or think about how the climate is changing, they're really thinking about, they're usually getting it from a popular news source. Whether it's Fox News or the New York Times, doesn't really matter. They're getting it. They're getting science distilled and kind of translated by someone. And those translations often don't tell you exactly, are we talking about past climates? Are we talking about future climates? Where are we talking about? Are we talking about something that's pertinent to Minnesota? Are we just talking about, coastal cities? Or are we, All of these questions usually aren't answered in the sources that we use. And one of the things that's really important is keeping in mind, there are certain types of science news that deal with revelations about things that have been underway that we did not know how to detect that we can now detect. So changes that are already ongoing. And then there's a whole other branch that runs very sophisticated numerical models of the atmosphere and tries to incorporate changes in the atmospheric chemistry, the very subtle changes in atmospheric chemistry that have these huge implications for our climate, and try and help us understand what the future climates might be like. So they might, in those projection studies, they might give us information about things that we have not yet observed, or that we did not, that we in fact know are not yet ongoing, but are expected to be happening more, or maybe more severely in the future. The third thing keep in mind is that we have a variable climate. You know, Minnesota's climate goes up and down all the time, and I don't just mean from winter to summer. I mean from the summer of 2019 to the summer of 2021, or from, you know, the kind of dry late 1980s to the incredibly wet early 1990s. We have these kind of normal swings that are built into our climate, and we have high amounts of variation because of where we are. We're in the middle of the continent. If the winds come out of the west, we get the Rockies. If the winds come out of the north, we get the Canadian tundra. If the winds come out of the south, we get the Gulf of Mexico. And as you know, larger scale weather patterns predispose us to more frequent winds from one of those directions, that has a big impact on what kind of weather we experience during that period. So it makes perfect sense that we would have a highly variable climate that kind of samples all of these extremes. Sometimes it samples them all. I mean, often it samples them all in 1 year, but we do get, you know, kind of stuck too. All right, so that's variations. But at the same time, we have ongoing, we call them trends, trends in our climate. That's sort of the statistical jargon or tool that climate scientists and statisticians and, you know, people who do a lot of work with numbers, that's the jargon that we use to describe an ongoing and important change in the behavior of some variable. All right, so think of it like this. It's not that every single year we're getting warmer. That's not true. Not even at a global level is that true. We still have variations globally that have us go up and down based on, you know, ocean patterns change, or there was a volcanic eruption, or certain influences that we maybe don't even understand yet induce some amount of normal variability. But what we have seen is that over time, we have a tendency to be warmer. And in Minnesota, we also have a tendency to be wetter. So we say, well, we're on this warming trend. We've been getting warmer, you know, since the beginning of the last century, but especially in the last 5 decades. Okay, that's the trend. But don't confuse that with meaning that every year is warmer than the year before, or that we're always warm, because we still have those variations built in. And this is where a lot of people get into trouble. They think, well, these suckers talking about how the global climate is changing, they don't understand how cold it is right now, so they must be wrong. Well, yeah, we can get cold. I'm going to talk about how what we now think of as cold really isn't that impressive historically. That's how much our climate has actually changed here in Minnesota. But let's just assume that, you know, we do have legitimately cold days still. That's true. And we do get legitimately cold variations, but they are variations from this predominant trend. It doesn't mean that, you know, 10 out of 10 years are going to be warmer than we've ever been. What it means is, on balance, more years than not are tending to be warmer than some kind of historical average. And the same is true with wetness. So having a highly variable climate does not disprove that you have a climate trend. Having, you know, a cold January and February does not disprove a point that I'm going to hammer hard today, that our winters are getting a lot warmer. Having one really cold morning doesn't disprove that our extremes of cold have been diminishing. And similarly, we have to be fair on the other side of this. Having one really warm winter day doesn't prove that our winters are warming, because occasional warm winter days have always been part of our climate. It's just that we tend to see more of them now. Having a hot summer day does not prove that our climate is changing. This might sound incredibly simple, but this is something that I have to do with the media all the time, and with other scientists who maybe are in different fields and don't understand this. It's an incredibly important, easily overlooked, and very simple piece of nuance that I think is important to bear in mind. Certainly in my line of work, it's important. And then the last thing is that we should seek more information and be refreshed some frequency. I can't tell you how frequently you need more information, but I would say this, the cadence that we have right now, where someone like me comes back every few years and gives you an update on how the climate is changing and what it means for Minnesota right now, that's probably pretty good for people who work or play outside. There are people that I work with in hydrogeology that probably need yearly updates, but most people don't need to stay on top of this at the same rate that I do. Okay, that's a long preamble, and now let's see. Okay, so here are most pronounced observed trends. On an annual basis, we have seen wetter and warmer conditions. This has been a major shift that we've observed. It's projected to continue, kind of a stepwise change, almost a shift, and we're going to take a look at that. On average, winter has become shorter with less cold, fewer extremes of cold, more snowfall, and less snow cover. Wow, every time I say that, that's a lot. We just said a lot. Somehow we're putting our winter into less time, and during that time, we're having less cold. Okay, that makes sense. But then we're increasing the amount of snow that we get, but that somehow results in less snow cover. And when you actually add up all those pieces, it does make sense. So for those of you who love outdoor winter recreation, you've been especially hard hit by this, because even in really good winters, we just don't have that same reliable snowpack with the same frequency that we used to have. The depth of the snow isn't as dependable, and the quality of the snow isn't as dependable. Certainly anyone in the Twin Cities area knows this. I mean, we've had terrible snow all winter. Up in northern Minnesota, they've actually had a very good winter for recreation. It's been cold. There have been not that many thaws, and it's been a fairly abundant snowfall season, especially in kind of the winter playgrounds of the Arrowhead region, along the kind of Lake Superior shore, especially inland and upland regions. Summers have been less cool than they used to be. I mean, I'd say that deliberately because we have not yet gotten hotter in most parts of Minnesota during the summertime. This is kind of counterintuitive, I know, but we haven't yet. And we've had more and larger kind of heavy rainfall events in the summertime. That's been probably the biggest change in summer, is that we've had more humidity hanging around for these big passing thunderstorms. And so we've had more intense rainfall events. So that's kind of been, those are the main trends: wetter and warmer with shorter winters, more snow, but less snow cover, and then summers that feature more frequent and heavier downpours and fewer cool nights. Well, then we could probably focus additionally on things that have not changed yet, just to make you feel kind of good about things, because sometimes that last slide, if you take it all in, it's actually a lot. These are fundamental changes in our climate, and it can feel like everything. And so for two reasons, I like to point out, help people relax a little bit. We do have major changes going on, but not everything is changing. So that's one reason. And then the other is, sometimes I'm working with or talking to people who really aren't, for whatever reason, they're not buying it yet. Now, I don't think there's any legitimacy to that, but like if you follow the science and understand the science, you would never conclude that. But I have to, meet people where they are and have them be comfortable. And it's good to be able to say, look, I'm not telling you that every single thing in our climate is getting worse. That would be dishonest. Right now, there's no evidence that our heat extremes or the number of hot days or anything have shown any signs of getting worse here in Minnesota. There's a slight difference in parts of northern Minnesota where we are starting to get hotter summers, but most of the state, and that's actually still very subtle up there, but most of the state, we really don't have a smoking gun signal for hotter summers yet. When we look at the projections, that's what I have in bold here. That is something that's likely to change by mid-century, if not sooner. Just all that extra heat in the system is eventually going to come and get us during the summertime. We don't know exactly when that'll start. But a lot of indications are that, we might have a decade yet, or maybe even more. Drought, as bad as 2021 was, it's not something that we've seen increasing in magnitude or frequency or aerial coverage over historical. We have very short memories, so we tend not to remember or even know or care about history. But Minnesota has seen brutal droughts, brutal episodes of drought, and not to downplay the misery that the last drought episode in 2021 brought to us, but it's just not the same as we certainly don't have any evidence that these kinds of things have gotten more common. There's a hint that droughts could become more intense as we get into the middle of the century. That would be tied to the increases in heat extremes. So then when you pair those increases in heat extremes with a nice long dry spell, you're going to get some really nasty drought conditions. It's just that right now we don't have any indication that we're flipping into a regime where we have lots of drought with high regularity or high frequency. So that kind of gives us mixed signals about the future. And then tornadoes and severe convective storms are not yet showing signs of becoming more numerous or becoming worse in Minnesota. And there's a big asterisk there, because that's true. We really have no evidence anywhere in most of the country, especially in the kind of traditional tornado alley, that tornadoes, severe convective thunderstorms with hail or high winds, like that, these are getting worse than we've ever seen them. But in Minnesota, we have kind of a normal severe weather season that we'd always expect, sometime in April or May to sometime in August or September. And then occasionally we'd see it sort of lurch beyond those boundaries a little bit. But we have seen a kind of aggressive expansion of that season. So last year we had a tornado watch in Minnesota in March. And of course, we had the last one of the season in December. We had confirmed tornadoes all over southern and southeastern Minnesota on December 15th. And that's just a very long potential severe weather window. And we saw the season getting expanded last year in other ways. And in other years, we've been seeing kind of the edges of our severe weather season get pushed. So even though tornadoes aren't getting worse necessarily, there are other aspects like, we're starting to see severe weather and tornado hazards at times of the year when we didn't used to expect them. Okay, let's start talking about, I cannot figure out how to get rid of this headline banner I don't know if other people can see it, but it's on my screen and it's right in my way. And so I'm just going to keep fussing with that. But what you should be looking at here are the changes in what we call the climate normals for precipitation. Climate normals, the just easiest way to think of it is it's kind of an adjusted, but it's a 30-year average for precipitation. And they're made at every major climate station around the country. So there's, hundreds of them that are made inside of Minnesota, but then they're also mapped in this kind of gridded format. So you can make nice kind of colorful maps showing how the precipitation has changed. And these particular maps are comparing each 30-year normal period to the 20th century average. And so what you see is it's not quite decade by decade, but generally from the beginning of the period to the end of the period, we've been getting wetter in Minnesota. And especially if you look at the last 3 decades, it's really started to take off. And you see in the lower right there with the most recent, the current normal period, we're as wet as we've ever been in much of Minnesota and also in the surrounding region. If we look at how our annual precipitation has changed, through the late part of the 20th century, there really was no change. I mean, we were wet at the beginning of the 20th century, and then we got dry for over 2 decades from the late 19-teens through the 1930s as part of that Dust Bowl era drought episode. That was kind of the heart of it, but it was really a prolonged dry period. And then we kind of resumed the normal climate, got kind of back to normal climate levels in the 1960s. No real change over time, kind of up, then down, then back up. But since about 1970, we've seen an increase in precipitation. And you see lots of ups and downs along the way. So again, that straight line, that diagonal line is just helpful for giving us a rate of change, telling us that, on average, a place in Minnesota has gotten wetter at a rate of about a little over 0.4 of an inch for annual precipitation per decade. So that most places in Minnesota at the end of the 2010s were, on average, 2.25 inches wetter than they had been just 5 decades ago. But this was actually, if you break it out by different parts of Minnesota, a little bit less change, less increase in northern Minnesota, and much more precipitation increase in southern Minnesota. So that's kind of how you get to these average values. So it's not that every year was wetter than the year before. It's just that over time, we've seen this increasing tendency to have years that were wetter, and in many cases, much wetter than we would have expected historically. Here in the Twin Cities area, kind of a complicated graph, but I think we can all grasp it here. Those blue bars, they correspond to the left axis, and that's how much of our annual precipitation, just total amount of annual precipitation, is coming from days where we receive at least 1 inch of precipitation. And we can think of those as kind of heavy precipitation days. It's the entry level for heavy precipitation. And you see, it's not exactly a perfect stair-step appearance, but over time, especially beginning in the middle of the 20th century, we see this sort of escalating pattern such that the blue bar is the tallest in the 2010s, meaning we had more of our annual precipitation coming from heavy precipitation than any other decade on record. And we see with the little dots on there, that just corresponds to the right axis, and that's the percentage of that annual precipitation. So one's the raw quantity and the other is the proportion of precipitation coming from heavy precipitation. And that too was at kind of an all-time high in the 2010s. We have some stations, about 38 of them, that have very long records. A lot of the stations that we have, they come and go in 10 or 20-year fits and starts, and they're being replaced constantly through the National Weather Service Cooperative Observer Program. But we do have about 38 that have hung in there for over 100 years. So if we just look at those 38 stations with at least 100 years of data, and we look at the average of each station's largest rainfall of the year, you could just plot it over time. And you see that the average of these values has been going up, not every single year, but you see a gradual kind of steady increase over most of that period, and then some evidence of kind of a sharp uptick in the last couple decades, where we have several days or several years where those average values are just much higher than we'd ever observed previously. We could do the same thing, except instead of looking at the average of all of those 38 stations, we're going to look at the maximum value from any of those 38 stations. And it's similar, but slightly different. What you really see is a widening of that distribution. It's not that every year we're seeing some part of the state having cataclysmic rainfall. It's just that with increasing frequency and also at increasing magnitude, we are starting to see rains that we had never seen before. And you can really see that begin kind of in the what it looks like the 1960s or so.
Kenny, the last slide, can you go back?
Yeah, sure.
The highest dot there in 2011, is that the Red River Valley floods?
No, the 2000, these are precipitation days. And
Days. Okay, I'm sorry.
these are days with precipitation. And so the Red River Valley floods most frequently are related to kind of prolonged and high level winter precipitation. Got some risk for that this year. Not as much related to the really intense rainfall events, which are more frequently associated with flash flooding on smaller streams and rivers, and then occasionally, helping some of those bigger river complexes get to high levels. But I think that highest year is probably 2000. I'm guessing it's 2012. This might be actually from the Two Harbors Station rainfall event in June of 2012. So most of these events are, at least wherever they occurred in the state, they're going to be local and locally memorable events, especially these ones at the top here, because if you're getting 8, 9, or 10 inches of rain in a day, you are almost certainly seeing some massive erosion and potentially catastrophic damage. So this particular chart shows, take those same 38 stations and then just compare them with each station's supposed 100-year rainfall value. And because you hear people saying, oh, these 100-year rainfalls are becoming more common. And well, what this graph shows is, yes, they are. But usually the way that people try and assess that themselves isn't quite right. You'll hear people say, well, we had one last year, and then there's one this year, so they must be getting more common. But, honestly, a extreme rainfall event in Rochester last year is considered to be independent from an extreme rainfall event in Thief River Falls this year. And so it's not, that observation in and of itself isn't a violation of how 100-year rainfalls would work. These are specific to the locations at which they occur. But what we can do is take those same 38 stations and just count the number of times that any one of them has a rainfall that exceeds its 100-year threshold. And these are very rare events. I mean, we're talking about, anywhere from 5.5 to almost 8 inches of rain falling in a calendar day, depending on where you are. Those are going to be rare occurrences. But what we see is that, beginning in the I guess that's the 1950s, we start getting them. Again, my screen is partially obscured by a kind of a bar here. But okay, now I can see some more stuff. So they start in the 1950s, but they get, there's not a perfect rhythm to them, but in general, they start getting closer and closer together. The interval between them is shrinking, meaning there's less time in between some station recording a 100-year rainfall, and they get kind of tightly clustered there in the 2010s. So this is some indication that there's an increase in frequency of these. Another thing our office looks at for gauging heavy rainfall is the so-called mega rain. It's actually kind of an arbitrary term. It was made up by our previous state climatologist. But it tells a nice story anyway. If you take 6 inches of rain, which is pretty close to it's a little bit lower than the average 100-year rainfall value around the state, but it's close. It's a nice round number too. And then you spread that 6-inch rainfall amount over at least 1,000 square miles, which would on average be about the size of a Minnesota county. Then you have a very large area massive rainfall event. And these things aren't real common. From 27 years from the 1970s through 1999, we only had 5 of them. And then in the next 22 years, from 2000 through 2021, we've had 11. So they're still very rare, but they have become about 2.5 times more common in the last couple decades compared to the 3 prior decades. And, when you get those kinds of events, so this is actually from June of 2012, the flood event I was just talking about that affected Moose Lake up to Duluth and up into the Two Harbors area. So it was a really huge rainfall event. And here's a before and here's an after. they got the kids, definitely got the kids off that soccer field. And here's Duluth. Again, these are courtesy of Minnesota Public Radio, by the way. We didn't take these pictures, but one neighborhood before and then after. So, and the point isn't, showing this kind of dramatic destruction from flooding, isn't to make you think that this is happening everywhere all the time. I mean, hopefully it was clear. They are still very rare events. Even the smaller ones that just qualify for 100-year rainfall somewhere are very rare events. It's just that they've become more common. They are becoming more common. Our hydroclimate is being intensified partially or largely because there's more moisture available. And one of the reasons there's more moisture available is because those global temperatures have risen. And as temperatures increase, so does the rate of evaporation of water, which means you pull more of that ocean water out of the ocean and put it into the air where it resides as humidity, which is the fuel for all of our precipitating weather systems. So it does make some sense. It's a little more complicated than that, but that's kind of the simple relationship.
Kenny,
Yes.
If I can ask, how is 100-year of rainfall identified? I mean, does this change over time? Is it how is that identified?
Really good question. 100-year rainfall event is, kind of a statistical creature based on however long and however much data gets crammed into a particular observing station's history. And the idea is it's not truly a 100-year rainfall, but it's a rainfall event that based on the history of that station and also including some information from other stations, because, maybe Minneapolis gets hit by a huge rainfall event, which we have in 1987 and also 1977, whereas somewhere like Forest Lake hasn't had rainfall of that level. That doesn't mean it couldn't happen in Forest Lake. It's just happened earlier in Minneapolis. So you kind of use.
Does it change over time? So like year to year, does that vary?
So I haven't yet described it.
Sorry.
So I'm sorry. So 100-year rainfall is defined as based on that station's climate record. It would be a rainfall that has a probability of occurring in any given year of 1%. So you kind of roughly expect it to happen, every 100 years. It is based on only the historical record. And in theory, these values could be updated over time and should change with time. But doing it is not just a statistical operation for each station, but they also have to be fed together through this kind of complex spatial, geographically statistical analysis. And that means that these things get updated infrequently. So the true kind of theoretical 100-year rainfall value should change every year as you get new information. But in fact, ours were defined first in 1960 in a paper that was written that long ago. And then, by ours, I mean in the United States. And then they were reestablished in the early 2010s. So it was 50 years in between. And it'll hopefully not be 50 years in between because we've learned a lot how to do this kind of stuff faster. But it's usually a big federal kind of National Weather Service or NOAA level statistical analysis that's required, because these end up these values end up going into statutes so that engineers have standards that they can use for designing roads and infrastructure and things like that. So it seems like it should be updated very frequently. So it was a really good question, but in practice, they're not. Okay, so precipitation is projected to keep increasing. So everything we talked about so far is what we've observed. We've seen these increases in precipitation. We're getting wetter. We had the wettest decade on record in the 2010s. We had more heavy precipitation than we'd ever observed in the 2010s. And by and large, we're seeing more extremes, even though they're not ubiquitous, they're not everywhere all the time. Basically, when we look at the projections, they tell us that we're going to have all the same ups and downs that we've always had, but that when we get to, say, 2050 or so, we would expect our hydroclimate to have increased in precipitation as much as we already have now. So just take the increases in precipitation that we've already observed and basically get them again over the next 30, 40 years, 20 to 40 years. And the same is true for days with heavy precipitation. We, in fact, expect more days with kind of high end, not necessarily catastrophic, but this particular map shows what's the 98th percentile or upper 2 percentile of rainfall events. So these would be, in most of Minnesota, 1.5 to 2.5 inch rainfall events, the kind of thing that happens maybe once or twice a year. And what this is saying is instead of happening 1 to 2 days a year, we'd maybe be 2 to 3 days a year. We get an additional day of this. It seems like a small change, right? You go from 1 to 2 or from 2 to 3 or maybe from 1 to 3, but that's actually an increase in 50% or 100% or even more. So that is a big change in frequency. And then when you factor in all of those ups and downs, some years you're probably not going to have any of those high achieving rainfall events. And then other years you might have 7 of them. So it just, the suggestion is precipitation is going to keep on coming, both at an annual level and with the kind of extremes that we've been talking about. Interestingly, during this period, snowfall across the state has increased. So, and I'm going to show you why that's interesting in a minute here, but the precipitation at snowfall, in the Twin Cities here, shown in those blue bars, was highest in the 1980s, but we were up there in the 2010s. And we see similar things in Duluth or out in Western Minnesota. We've got this great long-term station in the town of Milan. And we see this kind of everywhere, that the 2010s were maybe not at historical high points for snowfall, but they were up there. But look at that, that dot graph and line graph that I have also, that's the number of days with at least 4 inches of snow falling on an annual or seasonal average basis. And look at the 2010s, even though not the very snowiest decade on record, had more of that heavy snow on record than any other decade. And we see this all across Minnesota. So more precipitation, which we always think of as rain, but also we've been getting as much or more snow, and certainly more heavy snow. I mean, snow in every respect is behaving in the way that rainfall is, with more days with heavy snow, and some of those extremes of snowfall are increasing. And just over this weekend, if anyone was up, I mean, I know I was, but I'm kind of a freak about this stuff, but we had an incredibly heavy snowfall move through the central Twin Cities metropolitan area on, it was late in the night on Saturday night. It was about between 1 and 3 a.m. It snowed so hard. It was some of the hardest snow that we've seen in probably, you might have to go back 3 or 4 decades. I mean, the snowfall rates were 3 inches per hour. So in 2 hours, parts of the Twin Cities got 4 to 6 inches of snow, which is an awful lot. That would be a lot for half of a day, but getting it in 2 hours is kind of unbelievable. It was the equivalent of a cloudburst. Very, very heavy snow. So these kinds of things are happening a little more frequently also. The reason that's a little odd, or might seem counterintuitive, and by the way, I don't have any timers up, so you're just gonna give me the hook. Fran, when you're ready, just tell me to stop. This is temperature, the average or the normal temperatures, doing the same thing that we had done for precipitation. And look at how, again, it's not exactly decade by decade, but certainly the last few decades, we just got warmer and warmer and warmer. And these are all compared, taking the actual normal temperatures for that period and comparing them to the 20th century averages. And just, the most relative warmth in the country that we've ever experienced was in this current normals period. And certainly our region up in the upper middle, you see us, dark red. It's been a warm time for Minnesota and Wisconsin and our region in general. You see, as you get into parts of Iowa and Missouri, the warming isn't quite as strong. That's an interesting phenomena that we're still understanding. So if you look at how our temperature has changed, really the majority of that change has been, or the most significant part of the change has been since 1970, where we've on an average basis, most places in Minnesota have increased by about 2.5 degrees average temperature. That's averaged around the year. It's actually a really big change in about 5 decades. If you look at how the temperatures have changed, these are all maps that go right through 2021. The one on the left is just labeled in error. It does go through 2021. The annual average temperatures, about 3 degrees of total change in Minnesota since we began keeping these long-term records, but much faster in northern Minnesota than in southern Minnesota. If you move over to the middle map, that is the typical winter low temperatures. So that would be December, January, and February. And this is how much the temperatures have changed since basically the beginning or the turn of the 20th century. Look at that. Northern Minnesota, a typical winter night is now more than 7 degrees warmer than it was 100 some years ago. It's a big difference. To the right, we're looking at summertime high temperatures. So that's June, July, and August. And you see that, northern and central Minnesota definitely showing some signs of warming during the summertime period, summertime days, but southern Minnesota actually showing a small decrease. And however you look at it, you just got to admit that, the summertime temperatures are not changing with the same ferocity as wintertime temperatures. In the Twin Cities area where we do have an urban heat island, but you can, see we've got this, fairly steady increase. And then I drew in I guess it's a 9-year moving average. So you can see the sort of ups and downs along the way of that increase. Maybe looking at a place where there isn't an urban heat island like Milan, Minnesota. This goes actually right up through the current winter. And what we're looking at is the lowest temperature of the year every year. And then the upper portion in purplish, that would be the average of the 15 coldest days of winter. And again, it's not that every year the low temperatures are higher than the year before, but if you just look at the pattern of the dots, I mean, look at some of those recent years and then look to the left and see how common what we now experience as the coldest day of the year. Just see how common that used to be. How typical, this year in Milan, it was -25 was their lowest temperature, and last year was -27, and neither of those are outstanding. In fact, even if you look in 2019, when we had a real legitimate cold outbreak at the end of January with severe wind chills and all of that, that was -33 for an air temperature, and that's cold. That's really, really cold. But look to the left and see how common that kind of temperature used to be. And then you could look at it the other way and see how what used to get measured as really cold just doesn't happen anymore. And these are the kinds of things that we're seeing, again, across Minnesota in, whether you're in the prairies or in the cities or in the forested regions, we're seeing it everywhere. We just don't get cold with the same frequency or severity that we used to. And I've got this current winter is on this, and it's been a cold winter, but it just hasn't been outstandingly cold. It's just that we have gotten used to a much milder type of winter. And so now when we get something that used to be pretty typical, it feels really cold. Let me put this in perspective. International Falls is kind of informally known as the icebox of the nation. Cold weather battery testing has happened there, and they had a legitimately cold winter. Sure. I mean, lots of nights where they were in the 30s and even 40s below zero. That's cold. But that's also what you expect in International Falls. And even when you include this January, a typical January night in International Falls is now 9 degrees, more than 9 degrees warmer than at the beginning, in the middle of the 20th century, the beginning of its kind of serious climate record. So take a typical night from the 2010s or early 2020s, and it's going to be 9 degrees warmer in January than that kind of similar night plucked from the early 1950s. Big change. So we've had this warming of our winter, but we also have that increased precipitation. So let's start putting those pieces together. Snowfall, here's Milan, highest snowfall on record during the 2010s. But what's that orange trace? Well, this is the number of days between November and March where the low temperature remained above freezing. In other words, you were completely thawed. And, we expect those conditions in most winters, which is why you've got historically, between 20 and say 20 and 30 days where Milan, Minnesota would remain entirely above freezing at some point between November and March. But look at how it really changed, first in the 90s, then in the 2000s, and again in the 2010s, it just took off. So we had far more days. And I'm sorry, I was reading from the wrong axis. We'd have, 6 to 8 of those historically. And now, in the 2010s, we had 18. Look on the right side, those are the numbers that correspond to that graph. But it's telling you the same thing either way, qualitatively. It's telling you that we're getting thaw days at a much greater frequency than we used to, even though we're in a period where snowfall is relatively high. So another thing that we're seeing is, here's the Twin Cities, but we could do this anywhere. There's more days where it's raining during the winter time, more days where liquid precipitation is falling instead of snow, or maybe in addition to snow on the day before or the day after. But we're just looking at days where it only rained, where there was no snow at all. And in most of these days, the temperature was also above freezing. So this is it's something that we've always had. It's not super common, and it's still not super common. It's just become more common. And so the result is a degradation of our snowpack, less snow cover. This graph could be from anywhere. It shows Duluth, average annual snow depth average snow depth between November and March has declined pretty substantially. That's what those bar graphs show. And they correspond to the average snow depth on the left there. These other values are the days per November-March season. The blue line is showing about a 25% decrease from the 50s to the 2010s in the number of days between November and March with 6 inches of snow on the ground. Or below that is a 35% decrease in the number of days with a foot of snow on the ground. Or below that is about a 60% increase in the number of days with no snow on the ground. So we are seeing these kind of fundamental changes in winter, even though we've had a lot of snow. We have a harder time keeping it on the ground because it's been so much warmer. And this also has implications for snow quality. In parts of far northern Minnesota where winter is still pretty well insulated, you get very deep winter, so you can still get a good, fresh, playable snowpack. But in other parts of the state, central and southern Minnesota, where we're experiencing a lot more of those thaws and we're seeing a lot more of that winter rain, where it's just hard to have a high quality snowpack, even if we do get a lot of snow. For those who get out on area lakes for ice fishing or just track this because you like being outside, the typical ice season in Minnesota is shortened by a couple weeks in the last few decades. This set of charts is back to Milan, Minnesota. Again, it's a great 3-generation kind of rural climate observatory, so we love using it. It's part of the National Weather Service Cooperative Network. They've won some awards for their service and their length of service. So really, really high quality data. And you can either look at this as our growing seasons getting longer or our frost seasons getting shorter. The first day of fall is coming 5 to 8 days later, or I'm sorry, the first freezing day of fall is coming on average. You see the variations in there, but it's coming 5 to 8 days later over their period of record. Or the last freezing day of spring, final freeze of spring, is coming 9 to 14 days earlier. When you put that together, basically 2 to 3 weeks shorter 32-degree or frost season by, in Milan. And we see this again, it's not just Milan. That's just a good representative of our, climate data that we have. But we're seeing this everywhere. Shorter freeze seasons, longer growing seasons. And then meanwhile, since we're talking about temperature change, it's just worth pointing out that this is our summertime average daily high temperature averaged around Minnesota. And, you could see I circled 2021 there. It was a hot summer, especially in northern Minnesota. It was certainly a memorable summer for all of us. And it does stand out as one of the warmest ones we've had. And in northern Minnesota, it was the #1 summer for temperatures. But if you kind of look at the years before it, and this is kind of the difference. So let's go back to looking at the coldest days of the year here at Milan. You see how there's this sort of sense. You can just see it represented in the data that we've been getting, with all the ups and downs in there. There's just this tendency for the coldest days to not be as cold as they used to be. And they're now kind of starting to be warm enough. The coldest days are now as warm as they've ever been in some cases. So they're leaving that historical distribution. I don't know if you can see my cursor here, but I'm kind of circling some of these some of these more recent values where these blue things are the lowest temperatures recorded that year. And you just look to the left, and previously there was nothing that high on the record. So we've been seeing things like that. So there's already an indication that the cold conditions of winter have sort of warmed beyond anything that we really observed historically. Now, if we do that same thing with, say, average summertime high temperatures, even though 2021 has kind of a pretty outstanding look to it, if you look at previous years, or you look at the trajectory of that red squiggly line representing the 9-year moving average, you just don't see any real indication that we're heading off the charts yet. And this is why one of the things we have to do, when we think of, well, what evidence do we have that this particular element of the climate has changed, is ask, is it outside of some kind of historical range, or is there a sense that it's about to leave a historical range? And, based on the last couple years, I suppose someone could conclude that, but that's not really how the climate works. Once you factor in all those ups and downs, there's right now not any evidence yet. And in fact, if we look at the same thing and include the 2021 summer, so these are the hottest days of summer on the top, and then so the very hottest day of each summer on the top, temperature corresponds to the left axis. And then on the bottom, those more faint dots represent the average of the 15 hottest days of summer, average temperature. And, we had a really hot summer out there in 2021, but it just didn't stand out historically. Some of that's because the 1930s were so hot. Some of it's just that we just don't get hot the way we used to. But in any case, it's kind of stammer here because we could kind of go around and around with this too. Some of it, is it because there's more humidity? Possibly. But the point is there, with respect to temperatures, there really isn't any evidence yet that this kind of metric is off, leaving the charts, or that we're getting more hot days and the hottest days of summer are becoming hotter than they've ever been. That doesn't mean it won't happen. In fact, it's quite likely to. This is the most optimistic of all of the climate scenarios. This was run, these are a 1 generation older climate model now, but everything we've looked at shows that summer heat is coming. So even though we haven't gotten hotter yet, we'll get there at some point. It might be in the next 2 decades. It might be in the next, decade. We don't know exactly when. But this particular map shows that, with the most optimistic emissions scenario, one where we actually stabilize things within 30 years or so, do far better than we're expected to do, and kind of level off our emissions by the middle of the century. We still have enough extra gases that have already been committed to the atmosphere, and the atmosphere is still kind of catching up by getting warmer, that we would expect most parts of Minnesota to see, a doubling of their current number of 90-degree days by the time we get to the middle of the century. So that's kind of the baseline of what you expect. If the rosiest scenario we have, or one of the rosiest scenarios, tells us that we're still going to see a doubling of 90-degree days by the time we're 30, 40 years from now, then just imagine what the less optimistic scenarios suggest. I mean, so the hot weather hasn't arrived yet, but is almost certainly coming. And so the last thing I'll point out is that the drought of 2021, I'm going to show you two really kind of visually almost psychedelic looking graphs, but I think we can make sense of them. The one on the top is actually, it's really elegant. It's expressing how much of Minnesota is in a particular drought category, and then for kind of what amount of time. And so the shading is what you think it is. As you go from the outer reaches, the yellows and the light colors, you're going from kind of pre-drought conditions into entry level of drought conditions. And as you get into those darker oranges and reds, you're getting into more and more severe levels of drought conditions. And this first graph goes back from the 2021 drought, which is on the far right there. And then on the left side, you've got the year 2000, when this particular product began. And the point is that this was definitely a noteworthy and a bad drought, and we all hated it, and it was oppressive and all of that. But if you look back, well, one, there isn't any suggestion that these sorts of droughts are becoming a lot more common. You see just over the last 20 plus years, kind of every so many years, you kind of expect a statewide drought. This one was a bit worse than most of those other ones, but we do have, you see 2007 and 8 in there. We were in kind of a tough situation with drought, and then also in 2012. So that's kind of one way of looking at it, but we could look at something similar using a different index. And this particular index goes back now to 1895. And on the far right, you do see our spike from 2021 showing us, yeah, that was a really severe drought. But the thing is look, all those blue spikes pointing down, by the way, those would be wet years, really wet conditions. If you look to the left, though, look at all the other upward red spikes. There used to be more of them, and they used to be bigger. I mean, it's just true. What we think of, the way to think of this drought in 2021, and there's, parts of it still hanging on, so I don't want to pronounce it dead just yet, but the main episode from 2021 should be thought of not as, proof that our climate is changing or an evidence that this is how things are going, because we really, if you look at previous years, at a time where climate's already been changing for the last few decades, we don't really see an increase in drought frequency or severity during that time. If anything, we kind of see the opposite. But so I would characterize the drought of 2021 as an expected deviation from a predominantly wet pattern. And we had been in a very wet pattern in the 2000s and especially 2010s. And it had been a while since we'd had a real humdinger of a drought, and we knew one was coming. We didn't know exactly when it would be, and we know more will come. But there right now isn't any indication that our drought conditions, the drought type conditions are becoming more frequent in Minnesota, or that drought in general is becoming more frequent. That said, those same models that tell us, more 90-degree days and also more precipitation and more heavy precipitation also tell us that in the future we should expect slightly longer dry spells. And when those dry spells coming in between your precipitation events coincide with that hot weather, which we expect to arrive in greater numbers as we get into the future, well, that will probably lead us into some, pretty significant drought conditions. So even though we don't have good evidence that drought is going to become more common in Minnesota, we do have some evidence that future droughts might really press us in ways that some of our more recent ones and even some of the historic ones have not. So with all that said, I'm sure it's like 11 o'clock now, but here's the summary. The region's gotten wetter and warmer, and this has been driven by more frequent and heavy precipitation and also warmer winters. And the projections indicate that, basically what we've already experienced, we're going to get again. So the kind of warming that we've had will continue, and the kind of moistening that we've had will also continue. So that we'll get to the middle of the century with, temperatures that are a couple degrees higher than they are now, and with precipitation that on average is a couple inches wetter than now. And remember, along the way there, this is all just the best science that we have. We still expect those ups and downs, that kind of warm and cool and wet and dry variations or variability. That's kind of the signature and really permanent fixture in our climate. Therefore, drought, even cold outbreaks, will remain parts of our climate. So we're not saying that we're going to get warmer to the exclusion of cold events, or that we're getting wetter to the exclusion of drought. In fact, we expect these to include cold periods, Arctic outbreaks and drought episodes. It's just that I think we're going to continue to see the goalposts change. What we think of as cold now used to be pretty normal, and I think what we think of as cold now will be very uncommon in the future. And then similar things with precipitation. Again, hot weather has not yet worsened, but we do expect it to by the time we get to the middle of the century, and that's gonna be tough to deal with. I'm really thankful that we haven't really faced that yet, and definitely the outrageous heat wave in Portland, Oregon, and the Pacific Northwest this summer got everyone's attention, because it does tell us that it could be anyone at any time that experiences a level of heat that was just simply off the charts. So that's it for me. Thank you so much. And if there's time, I can take questions. Otherwise, if it's time for everyone to go to bed, we can stop that too. Thank you so much.
Thanks, Kenny.
I have a question if you're willing to take.
Oh, I see all the hints in the chat about what to do with that banner. All right. Well, too late for me. Thank you so much. Okay, go ahead.
What about air quality? I'm noticing personally that there's been many more days that we have bad air.
Yeah, there's two sources. Okay, so one is typical poor air quality. I'm sorry, I shouldn't have said two sources, because it's really more than that. We get bad air quality for two main reasons. One is that there's actual ozone forming near the ground, and that's bad. That's basically a chemical reaction to some of the things that are emitted through industrial processes. And it's a chemical reaction between that with sunlight and warm conditions. So in places like Denver, where you have a lot of sunny days, or in LA, which is more famous, you get smog, and the main ingredient of smog is ozone. Smog is a photochemical fog. And when it's dry, like it was this year, you're going to have more sunshine. And in those kinds of situations, when you have more sunshine, well, then it's easier to catalyze or to have that chemical reaction with the oxides that lead to photochemical, that can produce ozone and lead to that photochemical fog or smog. So there would be, especially when it's dry and sunny, you have a better chance of kind of ozone related air quality issues. Now, other air quality issues come from particulate matter or fine particles, the PM 2.5s, these very, very fine particles that are also emitted from similar industrial processes. And these form in conditions where you have what's called an inversion. And when you have an inversion, this is just where the warm air gets kind of trapped and can't rise because the air above it's actually warmer. And so you're just stuck with whatever air you have. And those can produce very poor air quality conditions. And we had additional counts of those this summer for similar reasons. The same conditions that tend to lead to smog also produce these inversions that can trap the particulates near the surface. But then the third piece is that during a hot, dry summer like the one we had a bunch of extra fire. Fire in northern Minnesota, fire in southern Canada, and fire out west. And we were getting smoke and particulates from those places too. So this was a very bad year for air quality in Minnesota. The worst on record, as far as I know, from our friends in the Pollution Control Agency. And although I don't think we should expect this to be the norm necessarily, there are a lot of indications that, as the climate continues to change, forests are going to be in transition. And when you think about what that means that, species in the forest, especially the vegetation, won't be as resilient and will be more susceptible to burning. And we should expect, over on average, maybe more summer forest fire smoke kind of wafting into our region. And we'd certainly seen that in other years prior to this one. It just seemed like we're getting more days in recent years where where you could smell the smoke a little bit. It kind of had that bad campfire smell. And so there is some evidence that air quality will be, in general, getting I don't want to say getting worse on average, but more of those compromised air quality days. But just remember, any year where you're really, really dry, and especially if you have a almost continental scale drought like we had this year in the West, you're going to have more of that really low air quality. And this was kind of an exceptional year. I wouldn't expect, every year to be like 2021. But yeah, really good question. Thanks.
What about wildfires expanding out of forest type areas to more like, the middle of the state, southern state? Are wildfires pretty much just a forest phenomena in Minnesota? Could they go through farmland if the croplands get dry?
Yeah, I would say that the risk for that, because of the way our land is fragmented, is a little bit lower. I mean, I certainly don't know, but most farmers out in central and southern Minnesota, they do everything they can to keep their crops wet. And so we'd really have to be in a disastrously dry period to, run out of water and have no sources of irrigation, and then the crops would be dry. I mean, wildfire on the prairies is very much a thing. We haven't really had any in our region that have gotten out of control and started encroaching on heavily populated areas. That type of phenomena that we saw in California is very much a creature of kind of uncontained boundary between the urban area and the forest. I mean, basically, we've had cities and their suburbs just creeping right into the forest. And in parts of California that are prone to being, just normally being very, very dry. But then when you add in a kind of mega drought condition, much drier and much more prone to burning. So I don't want to rule it out, because we've been surprised all over the place by what we've seen. But, when I talk to people who work in emergency management and really think about the big risks, our fire risks in terms of encroaching on urbanized areas or getting deeper, or maybe covering more area, our biggest concerns are in the forested areas, and then also in the peatlands, because the peatlands, when they start on fire, they can burn for a very long time, and they're releasing methane as they do, which is a whole other issue. So I wouldn't rule it out, but we haven't seen anything yet suggesting, more fire in the prairie regions necessarily, or spreading across the prairies into towns. But I would say that any tree species, and I don't have the atlas memorized at all, but any tree species that can't really handle the way the climate is changing is going to become susceptible to burning. But we were just talking about this in in our office where, there's some evidence that the prairies of southwestern Minnesota, they've gotten warmer, but they've gotten wetter much faster. And in a normal ecological landscape transition model, they would actually transition, even in the scientific and natural areas, they would transition from prairie to, if that were maintained, they would transition from prairie to maybe mixed prairie hardwood forest, or maybe even to a hardwood forest. But a lot of these remaining prairie lands are just surrounded by farms. So it's not clear where the trees would actually come from to establish there. So kind of a complex question that all that you're getting at, and I've gone off onto a tangent in answering it, but it's a really interesting question. And the short answer is, I'm not sure if I've seen anything suggesting that, roaring, raging wildfires deeper into central Minnesota are a major concern. But I mean, obviously, if we get really dry conditions, then all vegetation is fair game, right?
Thank you.
Thanks.
So,
I only give
oh.
very long answers, by the way.
Well, I don't mind if you give a long answer, because I ask long questions. So you were talking about that things are getting wetter, and we know that we've experienced it. So I live in the Twin Cities metro area. I'm right on the border of Minneapolis and St. Paul. And so I went out to look at flood risk for my area, thinking, oh, there's not going to be, I don't have to worry about a thing. I live on a street that if we were to get those conditions, will flood. So again, I'm right
whereabouts,
in
roughly where?
Oh, so I'm on Emerald Street between University Avenue and Franklin. So Prospect Park is to the west, and then so I'm literally on the border. So I'm in St. Paul, but I can see Minneapolis from where I live.
Yeah.
So so we're in a floodplain. So if we get enough rain, it said that, and I live in a condo development, our garages will flood. I mean, it didn't say maybe, it said will.
Yeah, absolutely.
So that's what we're looking at. So we're not, I mean, when we think of flooding, we're not thinking of you're near water or you're in a low-lying area. It can happen in the city.
It can. I mean, it's all a little bit relative. So I grew up in Minneapolis, and I was actually in the infamous superstorm of 1987. And for those of you who weren't here, that was a total rainfall cataclysm. We got 10 inches of rain in Minneapolis, and some of the western suburbs actually had more. And so Minnehaha Creek just exploded. I mean, it was unbelievable. And 9 Mile Creek became like 47 Mile Creek all of a sudden. It was just these huge torrents of water being churned out of these normally small systems. And, Lake Minnetonka swelled, and everything all the water got bigger. So, we had basement flooding. I lived on one of the hills in Minneapolis, though. So there were places way above me, and they had basement flooding too. But there were also places way below us, and they had the areas that were, the houses that were actually near the creek did much worse than anyone else. Mm-hmm. The houses that were kind of in the really depressed areas didn't do well. I mean, so water will find its way into low spots. It will find its way into basements and, garages, and it will pool wherever it can. But ultimately, it's looking to get, I mean, I shouldn't say it's looking, gravity compels it downward. Mm-hmm. And so, even on Emerald Street, well, you're in a flood zone, but you're still well above the river, which is where the water is ultimately going. And I'm not a hydrogeologist or a hydrogeomorphologist. I'm just a climate person. But yeah, I mean, basically rainfall rates seem to be increasing, and the frequency of high magnitude rainfall events are increasing, at least subtly. And so, what we thought of as flood risk 50 years ago is no longer valid. Again, the kinds of rains that inundate formerly protected areas are still pretty rare. But yeah, I mean, I think if you're in a place that would get 3 or 4 inches of rain and in a day, and that would, kind of wreak havoc, then you should think about what protections are available, because right now a 3 to 4 inch rainfall has an average occurrence in the Twin Cities area of about every 8 years.
Wow,
So,
okay.
and that interval has been shortening. It's
Mhm.
just that if we're talking about, 8 inches of rain, I mean, those types of events are becoming more common. We're seeing them happen more frequently somewhere, but they're still incredibly rare at a specific location, at a fixed location. So I wouldn't rule it out, but I'm certainly not going to guarantee that you'll see that kind of rainfall, this year or next year.
All right. Well, thank you.
Sure.
Hey, Kenny,
Thank-
there is a chat question
Yeah.
about how some different types of the population are acting on the information.
Okay, so we're Twyla's. I got it.
From
Candace.
Candace.
Candace's.
Oh, I'm sorry.
Do you see it? I can read it.
There we go. Yeah, I actually got a direct message from Twyla. Okay, Candace. How are farmers, public works departments, and city planning departments receiving and acting on this climate change information? So, Minnesota has been at the state government level has been pretty aggressive recently. So there's now a climate action framework in place. I think it's open for public review. So if you type in Minnesota Climate Action Framework, you'll actually get to a government document that talks about how Minnesota is sort of planning on facing some of this in 2 prongs. The one prong is adjusting to the changes that are already here and are coming, and how do we prepare ourselves for these things? And then the other is more like on the more commonly talked about side, which is how do we stop the climate from changing? So Minnesota's kind of got a 2-pronged approach, which everyone should have. I would say though, just in my experience, everyone is behind. I mean, Minnehaha Creek Watershed District, I've worked with them, and they have to be, think about where the Minnehaha Creek goes. I mean, it goes from Lake Minnetonka into Edina and then into Southwest Minneapolis. It is definitely among the very, very best funded and best supported watershed districts in the state. I mean, it's, goes through a lot of high value property with a lot of people who tend to be pretty involved civically. And they did not have the resources to cope with the very wet 2010s. It's just, some of this is a little bit out of our control, right? Because we don't, we move into houses and into neighborhoods that were already built. And they were already built at a time, a lot of us live in neighborhoods that were built during a drought. And so, anyone who lives in I used to live in the Lake Nokomis neighborhood, which was definitely built on a drained swamp during a dry period. So it seemed like, hey, we've got a real good chance of success here. This is all a long way of saying that for any of a number of reasons, even if you subtract the changing climate out of the equation, I think most Minnesota communities were not adequately prepared for the whole kind of suite of hazards that are normal climate entailed. Then the proof was in the pudding, because towns were getting wiped out by floods, 75 years ago, and they were getting wiped out by floods 50 years ago. And so it was already very hard to prepare for our climate and for worst case scenarios, because it's very expensive to build large enough drainage basins and large enough, culverts, and people just don't like paying for those kinds of projects. And so that's left us very susceptible. So we were already behind, and now that the climate has begun changing in the last several decades, we're more behind. And I would say that, farmers generally rely heavily on the big companies that provide their seed or their fertilizer to kind of help them be more resilient. And you see some land management practices, but a lot of times they're just relying on, getting the best advice they can from their extension officers. But the extension officers are, they're trying to keep up with changes too. And there's a lot of bottlenecking in that whole system. So I would say that you'll see among agriculture, among public works. I was just recording a presentation for public works folks today. And among lots of people, you see a lot of action of trying to do something, but you have to keep in mind that we're all pretty far behind.
So I have a question. One of the things that you haven't really touched on that's of interest to me is Lake Superior getting warmer?
Oh, Lake Superior is getting warmer.
That's how it seems to kayakers.
Yeah.
Or to people who want to go out to the ice caves.
Yeah. Lake Superior. So so the lake is like a complex system, and most of the weather observations that I use are really simple. It's like human beings going out in the morning where they live and taking measurements. They're measuring rainfall, or they're reading their thermometers, or now some of the modern versions of that are, kind of digital versions of the same thing. With lakes, there aren't people who, this is silly, there aren't people who live in the lake, right? And so the observations aren't as easy to come by. And it actually takes these kind of big projects and analyses of buoys and things like that to get data from Lake Superior. So it's not really the domain of climatologists, because it's more like a system that responds to the climate and to some other things too. But Jay Austin is a name, and there's some of his colleagues up on the North Shore and in Duluth, part of the Large Lakes Observatory. They have been studying Lake Superior and other Great Lakes for a while now, and they've shown that Lake Superior is warming very quickly, and in some cases, it's actually warming faster than some of the land areas around it. So that's just water temperatures are increasing. So yeah, it's a giant lake, and it's still predominantly a very cold water lake, but people with a lot of experience on it and research scientists are all saying that it has gotten warmer in recent years. So it's a good question. Thank you.
Are there any other questions? If not, we'll probably let the fascinating Kenny go.
Thanks, everybody.
Is there a primary source of the greenhouse gas? I imagine this is another talk entirely, probably. Or
I mean,
what's the
primary source?
Yeah, or what's the biggest, I guess you could say.
I mean, this is the price we pay for progress. Technology and progress.
Industrial revolution, or
basically oil, the combustion of oil, the combustion of coal, the sort of old familiar fossil fuels are still the lion's share of it. And then you can look at, who's using the most of those fossil fuels, or who is taking things out of the atmosphere or out of the landscape that can absorb some additional that can absorb. I'm sorry, who's taking, for example, trees would actually suck up additional greenhouse gases for us, but when you deforest them, they then can't do that. So that's a source. Kind of one source of input is from deforestation in the rainforests in the Amazon and in Africa and in Indonesia, but the much bigger source is just technological innovation over the past 75 to 150 years, where we've just been burning through energy at ever increasing rates as our global population has expanded. So those are the main sources. There are, some smaller inputs, but this is why we always focus on greenhouse gas emission reduction as a long-term strategy, because that's the largest source of this. Thank you. Good question. Oh, is it, I got some nice messages. I guess I have to do a better job at reading which ones are direct and which aren't. But thanks, everybody. I'm going to stick around here and just respond to some of these direct messages so that I could, because those are more private messages, I guess. So, but thanks for everybody. And if anyone has additional questions while I'm sticking around here, I'd be happy to take them.
Thank you so much.
Well,
This
thank
is
you.
great.
Thanks, Kenny.
Yeah.
Great job.
Thank
Great
you.
job.
Thank
Yep.
you.
Wonderful.
Great to have you back.
Thank you, Kenny.
Yeah,
So
I'll see
Joe-
y'all. I'll see y'all next year, maybe in
Thanks.
person.
Yeah, we hope.